Hi, my name is Zoren P. Mabunga, one of the author of this research paper. So the other authors are Dr. Jennifer de la Cruz, Miss Angelica Samortin, and Dr. Renato R. Maaliw III, and we are from Mapua University and Southern Luzon State University in the Philippines. So I'll be presenting our paper entitled Utilization of Different Wireless Technologies RSSI for Indoor Environment Classification Using Support Vector Machine. So at present, wireless technology has become an essential part of our daily life. Different wireless technologies play a key role in today's communications, and it will become more important in the coming years due to its continuous development. So Zigbee, Bluetooth, and Wi-Fi are three of the most common wireless technologies being used today. Such technologies could be used for organizing wireless sensor networks for solving a wide set of practical tasks such as in smart buildings, transportation and logistics, healthcare, energy control systems, entertainment, security, and in industrial applications. One of the performance indicator of such wireless technologies is the RSSI, which is the Receive Signal Strength Indicator. So it provides the measurement of the power received by a certain receiving device. Several studies were done over the past years in relation to these different wireless technologies receive signal strength indicator. Proscocailo et al. Developed a weighted trilateral localization method based on RSSI ranging for mine underground. So in their study, a hybrid filtering algorithm was used that reduced the positioning error and improved the personal positioning accuracy underground. Another paper was developed by Lee et al., which investigate the effects of RSSI in energy consumption. They also proposed an RSSI-aware algorithm and demonstrated the effectiveness of the algorithm in energy saving using Monte Carlo simulations. Lastly, Key et al. Developed a localization application based on RSSI, and in their study, principal component analysis and ensemble extreme learning machine technique was used for floor localization of tall buildings. So some of the gaps of this previous study that can be found in the literature mainly focus on the application of RSSI on localization and range estimation. Using RSSI for indoor localization provides the advantages of simple and low-cost implementation. So however, RSSI suffers from multiple interference, which is mainly due to the dynamic indoor environment, which results to inaccurate indoor localization. So the type of indoor environment was not considered in the previous studies, which greatly affects the localization accuracy. And the comparison of the performance of different wireless technologies RSSI were also not considered. So to address these gaps, this paper aims to develop an accurate model that can classify indoor environments using RSSI of different wireless technologies. Specifically, we aim to develop an indoor environment classification model using SVM or the Support Vector Machine Algorithm for three different wireless technologies. And we also aim to evaluate these models for indoor environment classification and to select which wireless technology provides the highest accuracy among those developed models. So the dataset that was used in this paper is consisting of RSSI values from the three transmitter nodes for each type of wireless technology, namely the Zigbee, the BLE, and the Wi-Fi. So these RSSI datasets were gathered from three different type of indoor environments, namely a small meeting room with low interference. The second type of environment was a small meeting room with high interference, and lastly, a small meeting room with average interference. So data pre-processing were done before the training of the model. The raw data were pre-processed by manual elimination of incomplete data. And data normalization was also done by using the presented equation as part of the data pre-processing stage. The data normalization is used to have a common scale without altering the difference in span of values by having a value of 0 to 1. So three classifier model were developed using the machine learning toolbox of MATLAB. The tree model corresponds to the three different wireless technologies that were used in the determination of RSSI at different indoor environment type. Support vector machine algorithm, or the SVM, with Gaussian kernel was used for the training of the classifier model. This algorithm was chosen due to its performance for data with nonlinear relationship, such as the relationship between the RSSI values and the level of interference in an indoor environment setting. Using the Gaussian kernel also allow us to transform the original feature spaces into a higher dimension feature spaces, where each data point has n features for each support vector. So for the testing and evaluation of each model, holdout validation was used with 30% held out. And to compare the performance of the three models that was developed, their accuracy on the test set was used. So the data set was divided into two different sets, which is called the training and the test data. So the training data was used solely for the training of the classifier model, and the test set was used to test and evaluate the developed model. So this table presents the sample raw data that was gathered using the Zigbee technology from three nodes, node A, node B, and node C, and their equivalent environment type. So table 2 again presents the sample raw data for the Bluetooth low energy technology from three different nodes also, node A, node B, and node C, and their equivalent environment type. So table 3 is for the raw data for the Wi-Fi technology, RSSI, from the three different nodes for the three different environment type. So this table, table 4, presents the clean and normalized data set after data normalization. So as you can see, the values for the RSSI for node A, node B, and node C has values ranging from 0 to 1. So this figure, figure 1, is the confusion matrix for the classifier model of the Zigbee technology. So as you can see, we have a true positive results of 91.8% for the environment type 1, 0% for the environment type 2, and 37.5% for environment type 3 for the Zigbee technology model. So for the Bluetooth low energy technology, the developed model for this technology was able to obtain a 98% accuracy or true positive result for environment type 1, 37.5% true positive accuracy for environment type 2, and 87.5% true positive result for environment type 3. So lastly, for the Wi-Fi technology, 98% true positive was able to obtain for environment type 1, 31.2% for environment type 2, and 95% for the environment type 3. So those are the true positive results. So to summarize the accuracy of the three classifier model, for the Zigbee, the overall accuracy was 57.1%. It was followed by the Bluetooth low energy with 84.8%, and Wi-Fi technology was able to obtain in an 86.7% accuracy, which is the highest among the three models. So to conclude, in this paper, we were able to develop three classifier models using the RSSI of three different wireless technology, namely the Zigbee, the BLE, and Wi-Fi. The dataset that was used in this paper was clean and normalized, which result to a better accuracy for the developed models. Based on the results obtained, there is a less true positive results for the environment too. This is mainly due to the less data for this type of environment compared to the other type of environment. The overall accuracy of the three classifier model was compared, which results to the classifier model using the Wi-Fi RSSI as the best model since it was able to obtain the highest overall accuracy of 86.7%. So for future works, this paper can be used to improve the existing research on indoor localization using RSSI. Since RSSI is dependent on the type of environment, it is therefore important to first identify the type of environment before making an approximation of the location of a certain object in an indoor setting. So that will be all, and thank you for listening. So keep safe, everyone. Thank you.